Hello class, today we're going to go over section 5.3a, logarithmic equations. Now, logarithmic equations can be solved typically by isolating the logarithm itself and then turning that logarithm into an exponential. So let's look at an example here. So, it says solve for log base 3 of x equals negative 8 by converting to exponential form and verify the solution graphically. Okay, so if we start out with 4 log base 3 of x equals negative 8, the first thing we're going to do is isolate the logarithm. So we're going to divide by 4. This is going to give us the log base 3 of x equals negative 2. Then what we want to do is convert from this logarithmic form to the exponential form. The conversion there is 3 to the negative 2 power equals x. Now keep in mind that 3 to the negative 2 power is the same thing as 1 over 3 squared, and 3 squared is 9. So essentially, if we simplify here, x is 1/9. You can kind of see that worked out here as well. Now if we were to verify this graphically, what we would want to do is we'd want to let y1 in our graphing calculator be 4 log base 3 of x, and we'd want y2 in our calculator to be negative 8. And then we would do second calc value for the intersection here. We'd run the intersection function, and we would also be able to find this point 1/9 and negative 8. So that is verifiable if you graph it on a graphing calculator. Like I said, graph both functions. Use the, I believe it's the second trace function. So yes, it's the second trace. So the blue second button, the trace button, which brings you to the calc interface, where you can indeed do the intersection, highlight both functions, and guess the point by hitting enter. Now let's look at this function. Okay, here we have 6 plus 3 natural log of x equals 12. I want to solve that by converting to the exponential form and verify the solution graphically. Alright, so 6 plus 3 natural log x equals 12. Got to isolate the logarithm here. It's a natural logarithm, but we still need to isolate it. So I'm going to start out by subtracting 6. This is going to leave me with 3 natural log of x equals 12. 12 minus 6 is, get ahead of yourself there. 12 minus 6 is 6. It leaves you with a 6 here. Then we're going to divide by 3. That leaves us with the natural log of x equals 2. Okay. Now, the natural logarithm has a base of e. So if I'm converting from the natural logarithm to an exponential function, it should look like e squared equals x. And that would be our answer. Now you can find the numeric answer for that by typing that in your graphing calculator as well. But many times we'll leave it here as just e squared. You can also check yourself on your graphing calculator by graphing y1 is the 6 plus the 3 natural log of x, and y2 is the 12, and you can check their intersection point. If you check their intersection point, it turns out to be 7.38906, which is indeed e squared. It's just the numeric value of e squared. Remember, e is just a number. Now let's try this one. This one's a little more intense and difficult here. We've got the natural log of x plus 3 equals the natural log of x plus 4. Okay, notice here the 3 is outside of the logarithm, the 4 is inside of the logarithm. What we need to do is we need to get the natural logarithms together here. So if this is our original, I'm going to start out by subtracting the natural log of x. This isn't the only way you can do it, but this is the way I'm going to suggest you do it starting out. So here we have 3 equals the natural log of x plus 4 minus the natural log of x. And now, because I have it set up where my natural logs are all on one side, and that's the only thing that's on that side is natural logs here, I can combine these natural logs. I can do that when at the subtraction here, I can bring everything to the inside and make it a division. So I'm looking at the natural log of x plus 4 over x. Okay, keep in mind that the natural log has base e here. So I can make this e to the third equals x plus 4 over x. Okay, then I can multiply this x over to the other side. So it's going to be x e to the third equals x plus 4. Then I'm going to get my x's together by subtracting x over. I'm going to get x e to the third minus x equals 4. I'm going to pull an x out of here. And that's going to leave me with an x times e to the third minus 1 equals 4. I'm going to divide both sides here by e to the third minus 1. So that my final answer is x equals 4 over e to the third minus 1. Okay. Like I said, not the only way there, but the way that I would do it. And as you could tell, it works its way through over here as well with the actual slides on the PowerPoint. Okay. Now let's look at a word problem. In this word problem it says, in an effort to reduce climate change, it has been proposed that a tax be levied based on emissions of carbon dioxide into the atmosphere. The cost-benefit equation, the natural log of 1 minus p, equals negative 0.0034 minus 0.0053t, estimates the relationship between the percent reduction of emissions of carbon dioxide p as a decimal and the tax t in dollars per ton of carbon. Solve the equation for p, the estimated percent reduction in emissions. Okay. So, we want to solve the equation for p by writing the equation in exponential form. So the equation starts out here as the natural log of 1 minus p equals negative 0.0034 minus 0.0053t. If I convert that to exponential form, because natural log has a base of e, then I essentially have 1 minus p equals e raised to the negative 0.0034 minus 0.0053t. Now all I have to do here to solve for p is essentially switch the p and the e, but here, if you want to take it an extra step, all we're really doing is subtracting 1 over here. So that you're technically, I'll add you an extra step in here. You're technically at negative 1 plus e to the negative 0.0034 minus 0.0053t. Okay, and then you're going to divide by that negative 1 that's in front of that p, and that's where you get p equals 1 minus e raised to the negative 0.0034 minus 0.0053t. We've now solved that equation for t. In solving that equation for t, if I want to figure out part b, all I have to do is now substitute 100 in for the t in this equation we just solved for. Okay, so let's look at what that would look like. So if I put 100 in for t here, I can now type that equation into my calculator, and it should reduce down to 0.4134, which if we convert it to a percent is about approximately 41.3% if we round to one decimal place with the percent. You do have an e button on your calculator, so you should be able to raise that e to that exponent. No problem at all. And that concludes 5.3a.